Okay, sorry. Getting all organized today. So function notation, if you had watched Friday's video, I have to check that assignment today. It's really just a fancy way to write an equation. So we've been writing equations forever here. We now write it as that f of x instead of y equals. Sorry, my technology is not my friend today. Can you turn on, please? There we go. So the main goal today is just get used to that. It is something we will see the rest of the year, since once again, we're kind of dealing with functions the rest of the year. Sometimes we will write y equals, but sometimes this function notation will pop back up and we want to know what the heck it means. So give me a second as I'm struggling to get things set up today. Hey, did everyone have a good weekend?
Yeah.
Was anyone do anything fun? Great. I got my Christmas tree, that was exciting. How many people get a real Christmas tree? Only 3. Some people maybe don't have one, some people do the fake deal. I respect it, but real Christmas trees are kind of a pain in the butt. / wicked expensive, guys. I paid for the Christmas tree, it was $90. And it's not even that big. And I was going for the cheap one. The expensive one were like.
Spamming you, Mr. Sherman.
I know. I was like, God, I'm gonna go to just go chop down a tree in my backyard at this point. But it doesn't look so pretty. Okay, so function notation. You had a little intro last week, but let's just look at these. Now, I said I introduced it with f of x, but it can be any letter. So we notice at the top of this worksheet, there are 4 functions, and we can tell that they're different because they're denoted with different letters. So we have g of x, f of x, h of x, and j of x. So what happens is if I had just given you 4 equations and I would say like, hey, if x equals 10, find y, you'd be like, well, what equation do I plug into? I don't know. So this helps us tell the difference between which one we are using. So just as a reminder, when I'm looking at A, it says G, we say this as G of 10. So what that means is I'm going to pick the G function. So for the first two, I'm going to kind of like show my workout in detail if you're like doing little shortcuts. So I'm going to rewrite it just to remind myself what I'm using. I'm using the G function, which is this. And when it says G of 10, that means where the x is in the function, I'm going to replace it with 10. Kind of makes sense like logically. I'm just replacing a variable with a number. So basically it's telling me that this is what I'm plugging in to my equation. So now on the right side, I'm going to plug in 10. So really it's just a fancy way to tell me what function am I using and what am I plugging into it. You just simplify this. -3 times 10 is -30, plus 1 is -29. So we would write my answer as G of 10 equals -29. And that's what your answer would look like. So right now, just looking at that, I know what function I used, I know what I plugged in, and then I know what I got out. We call that the output. So my output was -29. So we're not actually doing, the work we're doing isn't actually different. It's just making sure the setup, I understand what goes where and what I am plugging into. So f of 3, I'm going to use the f of x function. All right, I love it. So you don't even really need to write it. I'm just kind of showing what I'm doing. That's 7. So where I see x, I'm plugging in 3. I do highly suggest, and you will see me do it for every problem, when you take a number and you input it into an equation, I suggest it's in parentheses. Little things happen sometimes when you're squaring, like a negative. It's better to just use your parentheses. And it shows that you're kind of putting something into it. So on this side, I'm going to do x squared plus 7. That's not bad. I'm just going to simplify it. So the actual math works out new. 3 squared is 9. 9 plus 7 is 16. But that is how you should write your answer. Don't just write 16. It should be f of 3 equals 16. So I know function, input, output. Okay, these really, we can do a million of these. That's why I'm not gonna write the original, I just look up here. So h of negative 2 is gonna equal 12 over negative 2. And that would be what, negative 6? So just kind of getting used to the notation. So can you guys try D, E, F? And there's a few other things I want to leave at the bottom. Just to see, are you okay with it? I know you practiced a little bit last week, but let's be honest, when you do things at home, it's probably a little bit harder to concentrate. Just try DEF, just in general, you're plugging in, do you understand where you're plugging into, how to write the answer? Once again, the actual math isn't too bad. You can always use a calculator too if you get a tricky one, or if you're just feeling a little tired on Monday, I feel you. I'll give you one more minute. All right, so let's look at them if you're kind of still finishing up, that's fine, just a little bit of practice for you. So J of 7, okay, so I'm gonna look at my J function. I'm gonna throw a 7 in where I see X, so that would be 2 times 7 plus 9. So I just kind of do my math out, you can just throw it in the calculator. 14 plus 9, my final answer would be J of 7 equals 23. That's how your answer should be written. Any problems with Z? All right, E, F of negative 2. So, okay, F of negative 2 and the X, okay, F. So this is where the parentheses are gonna matter, especially if you're using a calculator. So just as a reminder, saying this and saying this are two different things, okay? So this is where you need to be careful, but the calculator is my best friend. I get like super lazy and I just like plug things in. But if you plug it in like this, it does 2 squared, which is 4, and then it makes it negative, so that would be negative 4, which we don't want. We want negative 2 squared, which is negative 2 times negative 2, which is positive 4. So just little things can kind of mess you up, so parentheses are your friends, especially when you're using calculators, you need to use parentheses as well. But that would be 4 plus 7, so 11. There we go. So once again, writing your answer like that. And then J of negative 1/2. Okay, let me think. J function. Plug in 2 times negative 1/2 plus 9. Well, 2 times negative 1/2 would be negative 1 plus 9 would be 8. Any problems as you were trying those on your own? Once again, it's not. The nice thing is it's not like any new mathematical crazy thing. It's just knowing like if you see this, what the heck does it mean type thing. So h of 0 won't be bad either. In the h function, we're gonna plug in 0. Oh, schnikers, we get a 0 in the denominator. We can't divide by 0. Hey, does everyone know why you can't divide by 0? Huh?
I said friends, don't let friends divide by 0.
But why not? Can someone tell me the reason why? Like, I know your teachers always told you can't divide by 0. Does anyone know why?
Because anything divided or multiplied by 0 is still 0.
No.
Oh,
No, because the answer to this is not zero.
oh,
It'd be less than
undefined, my
one.
bad.
The answer of this is undefined.
Yeah.
Okay. No, like, you go through some of the, and you're like, why don't I know that? So ready, here's the explanation. I feel like I just need to tell people this. When you divide, you put things in groups, right? So if I have 10 things and I divide it by 5, so if I take 10 things and put it in 5 groups, how much are in each group? 2, right? Okay. If I take 20 things and I put it in 4 groups, how many things are in each group?
5.
If I take 12 things and put it in 0 groups, how many things are in each group?
You can't do that.
You can't do that. You can't divide by 0, because that's just saying I'm taking all this stuff and I'm trying to put it into nothing. Okay, that's why you can't divide by 0. That's why if you didn't know that, you just have to. I feel like, and I do that sometimes too. I'm like, this is just a rule, but like it's a rule for a reason. You can't divide by 0 because you can't put things into new groups. So, please don't write 0 as the answer. The answer is undefined. So just as a heads up there. And then we see some other stuff happening. So maybe there's more than one function, or maybe we're kind of doing something to a function. So as an H here, keep wanting to say numbers. We're basically just gonna kind of do this as 2 separate problems and then add the answers. So when I say g of 2, kind of off to the side, I'm gonna do g of 2. I can do that. I look at my g function, -3 times 2 plus 1. I figure out what that answer is. -6 plus 1 is -5. Okay, so that wasn't bad, but that's only half of what I need. Because I also need h of -3. So I just kind of like split them up, do them on their own. H of -3 is going to be 12 over -3, which is going to come out to -4. And then you have to remember in the end, we're trying to add these 2 functions together, so I'm going to add those 2 answers together. And my final answer would be, I'm just going to write here, g of 2 plus h of -3 equals, because I'm too lazy to write the whole thing back out, -5 plus -4 is -9. And that would be your answer. So I got kind of lazy and just wrote equals, but you should write the original back out if you don't have the space. 2 times f of -1. So we're multiplying a function, but we're plugging into the function. You always plug into the function first. So I'm gonna find what f of -1 is. So I can just do it right below. In the f function, -1, I'm gonna do -1 squared plus 7. Remember, -1 squared is 1, plus 7 is 8, so I can go to 8. And now that I know that f of -1 is 8, the problem is telling me I need to multiply that answer by 2. So I would say 2 times f of -1 equals 16. Right? F of -1 is 8, double that is 16. So as we go on, kind of fancy things happen there. All right, so there's a few other things under that, I just can't see them, so let me move this. Oh yeah, oh, these ones are done, right? Oh, okay. I'm gonna have to get the actual worksheet. So now this is where we get, like, this is the good stuff. This is the stuff I didn't really want to show you in the video, because I said it might confuse you, but it's actually not too bad once you understand just where things go. Right? It's just, where do I plug this in? Okay, so I'm gonna grab the worksheet because I can't do my functions anymore. So we look and we say, find x if g of x equals 16. So think about it. I go back up. I'm just gonna write the g of x function, because once again, I have them in front of me. Okay. So before, that's not set up how the other ones were. So I'm automatically like, what's happening here? So find x, where we were given x before, if g of x is 16. Just think about what that's saying. G of x is 16. You're gonna find x. So we're basically just plugging in, it's giving us the output. We need to find the input in order to get that. I tend to find if I write this out, it kind of makes sense to me. Because I can see, I'm just gonna replace g of x with 16, so this whole side gets replaced, and then my main goal is to solve for this. So this one I'm gonna subtract 1. I get 15 equals negative 3x, and I'm going to divide. And x would equal negative 5. And that's just how you would write your answer. That would be our input. And go from there. So same thing, so here's how I would set up k. I would say, ooh, okay, I'm gonna use the h of x function, I'm just gonna write it out. H of x equals 12 over x, okay? It's telling me that h of x, that this equals negative 2. Ooh, how do I solve for x in this case? What should I do?
Would you multiply x by both sides?
Beautiful, you can multiply x. You could make that, you could also put this over 1 and make it a proportion if you wanted to. But to get rid of a fraction, you just multiply by what's in the denominator, so that's kind of a little funky. But that gives you negative 2x equals 12. And now we have an equation that we can kind of more easily solve and go from there. So, oh, why did we put that one on there? Okay, I was gonna have you do the next one, but I'm gonna go. Okay. All right, last one like that, and then just a few other things on the back. Okay, that's a good stuff. What do we got? F of x, I'm just writing the function, equals x squared plus 7. I think about what I have. I have f of x. I'm gonna solve, I'm gonna subtract 7. What does that come out? 16. We do a lot of solving quadratics later when there's that x squared. I'm just gonna tell you now how to do this one. I wouldn't do this to you on your own. You would take the square root to get rid of the squared. And so we call that the opposite of that. And x would just equal 4. We do more quadratics later, but I didn't want to leave you that one on your own. For now, we're going to skip m and n. They're stars because we don't really need to do them. And I want to get through a few other things first. So if you have time, we might go back to those. So what we want to start doing is kind of talking about, okay, we have all these functions. I'm getting used to plugging into them. But I want to relate it. We're going to be talking a little bit about graphing in a second. So I want to relate it to graphs. So when I'm talking about any function, it doesn't matter, f, h, g, k, whatever, it doesn't, this isn't even referring to those ones, it could be any function. What the heck are these numbers meaning in terms of like how I can relate it to a point? So remember, when I'm talking about my input, that's my x, and then my output, when we think about a point, we think about it as the y. So if I'm ever given a point like this, and I say write it as a coordinate point, aka just as like a point on the ground, this is your x, that is your y. That's it. So it's just a fancy way to write a point. That's all we're really doing. So once again, it doesn't really matter the function it's going into. Well, it might in a second when we're looking at a graph. But the input is your x, the output is your y. So this, you don't really have to do any work, is 2, 7, done. You guys write the C and D points. That should be pretty quick. Once again, that took 0 amounts of work. It's just understanding that when I say that, it's the x and that's the y, x, y. That'll be 1, -1, and 3, 9. So we're just gonna keep that in the back of our head because that's gonna be helpful in a second when we look at a graph. So can you flip a root over? And let's actually look at a graph. All right, so we're just gonna try to read this graph. Okay, let's read graphs, no problem. If I'm looking over here, it tells me this is f of x. It's a nice little curvy thing going on. And it's just asking me some questions. So I'm gonna kind of keep that point idea in the back of my mind. So when I'm thinking of f of -4, so these are all the f functions. When this is -4, that's my input. This is what I usually do, just because I need to kind of think of it this way too. I'm just thinking, oh, -4 is my input, what's my output? Okay, so I can kind of do this. I'm gonna go to x is -4. So on the x-axis, I'm gonna go over to -1, 2, 3, 4. And then all you're really gonna do is follow it up to where your graph meets it and find the y. So we're gonna say that y is 2. So that would equal 2. So f of 0, that's the point 0, comma what? So what is my answer? So go to 0. That's just the origin. Where does it hit the graph? It hits the graph right there at the origin. And that's the point 0, comma 0. So f of 0 equals 0. So it's just like, it's kind of like stuff we know how to do, but it kind of feels weird, I don't know. So it's just getting used to what you have, what you're looking for. So what I do when I see this is I say 3, comma what? So I just go over to 3. 1, 2, 3. I find where it hits my graph. It's not a perfect point, so I'm just gonna estimate. That's about what, like -1.
0.8.
Yeah, like whatever you put it, I give it to you. -1.8, sounds good to me. If you would put something around that, you would get it. So we would say that f of 3 equals -1.8. Right now, can everyone find what's f of -5?
Zero.
It should be 0. So I just remind myself, what the heck does this mean? Oh, it just means I'm really looking for a point and it's giving me x at the point. So -5, I go over to x is -5, and it looks like it just goes right through there. So that would be 0, so we would write f of -5 equals 0. Okay. So all of these, it gave me an x, and I was finding its output, which on a graph we do usually tend to say is y, but in this case is labeled as f of x. So now we're looking at these other ones. We're saying, well, what the heck do I do here? Find x when f of x equals 2. Think of it as a point. Find x if the output is 2. So we're just kind of doing the point backwards. So you just have to remember that first one we had x's, so we were on the x-axis. And this one we have the y, so we go to the y-axis. On the y-axis, I'm going to go to 2. Now be careful, because when I look across, it hits in 2 different places. So you have 2 different inputs that give you that output. So just be careful. So I have the point -4,2, and I also have the point, I'm going to say that's -0.82. So x could equal -4 or -0.8 or anything around that. I mean, obviously if it's kind of not on an exact thing, then you just kind of estimate / guess. But just be careful when you're given a y, you can have more than one x, that's perfectly fine. But it's just like a weird, like getting used to reading it. So find x, so that means find x when f of x is 0. So I'm gonna go to my y-axis or my f of x-axis, my outputs. I'm gonna think about, this is 0, right? Where does it hitting? This one is also hitting in 2 places. It's not always gonna hit in 2 places. Because if I pick something down here, or right here, it would only hit once. So it hit 0 at -5, but it also hits 0 at 0. So your x could be -5 always here. We do a lot of graphing as we move on in the year. We're not necessarily gonna do a ton like kind of going back and forth with function notation. But it's good, our main goal today is just to kind of relate what we know to this new notation. So we can read graphs with it, depending on what information we're given, whether we're given the input or the output. So just as a heads up, I always kind of think about it as a point. I think that's the easiest way to do it. But if you have another way that's making sense in your brain, go for it. Oh my gosh, time is a flying. Any questions on that one? Yes,
I know about it.
absolutely. Go ahead. There's passes right up there. All right. Sorry, I had to get in. I just have to get in the next little part, and then you guys can have a few minutes. So, the next part, it's just a little bit of vocab. And the actual math behind it's not too terrible. It's stuff that we've done before, like just plugging into functions. But it says find the range given the domain, and maybe those are words we haven't heard before, so I just do want to go over those quickly with you. What the heck do those words mean if you're given them? And then what do we do? Because there's like all sorts of numbers here. So somewhere, I don't care where, you can just make a note to yourself. When I say domain, that's your input values. We call those the x's sometimes. Like, what are you putting into the function? That's called your domain. Now the range, it's annoying when we've heard about range before in terms of like mean, median, mode range. This is not the same thing. So same word, not same definition. The range is just what we would call our output values. So those are f of x's, or you might think of them as your y's. But that's what that means. So basically it's just saying, find the outputs if we're given all these inputs, or find the f of x's if we're given all these x's. It's just a fancy way to say it. Basically, here's what you would do. You would say, okay, I have this function f of x. Now I have this big old list of numbers. That's what we call a domain. It's just there's more than one input, so we call that our list of inputs. We basically just need to plug each of these in individually to find their outputs. So I would just start by saying f of, I'm going to start with -4, and then I'm going to do f of -2, and I'm going to do f of 0, and then I'm going to go answer my phone. See if you can kind of figure out and start that one. Hello? Hey. No one's over here. Yes. Yeah. Oh, I don't know. Maybe that makes sense. Me too. Oh, do you think that's what she meant? Maybe that is what she meant, because it made no sense to me. Because I was like, I cover Cammy every single day, second lunch. I emailed her. Well, I thought you want me to cover second lunch, you can cover it for me. But maybe she means, because I always call that third lunch. Oh. Oh, it does? What does it stand for? Yeah. Oh, okay. Well, I can just do, I'll do Kendall, because you know what, I have covered Kendall before, and I think she has third. Yeah. So I'm gonna go off with actually covering third lunch. Good at calling that one, because I was so confused. I think it is too, when you just said that, because I think I've covered her before, and she doesn't. All right, thank you, Beth. Such a drama. They mess it up every single day. Miracle. Okay, anyways, that was a kind of this problem. So we have f of 0. We also need to find f of 1 and f of 3. So basically it's telling us that each of those are going to be inputs, and I'm going to find the outputs that go with them. So for each of these, I'm just going to plug it in. So that's in the f function, I'm plugging in -4. So we would do -4 squared minus 2. Once again, the math is actually pretty quick. -4 squared is 16 minus 2 is 14. Okay. Then we just do the next one. -2 squared would be +4, minus 2 would be 2. 0 squared is just 0, minus 2 is -2. 1 squared is 1, minus 2 is -1. And 3 squared is 9, minus 2 is 7. Okay, so we have these whole bunch of answers here. We write our range the same way the domain was given to us. So we would write that the range of this They have a little curly bracket. Some people can't do those. You can just do like a parenthesis, it's fine. I like that portion. Guys, no, when you like doodle in your notebook, is anyone a doodler in here? Okay, well, I'm a doodler. I like literally doodle math symbols. So like my notebooks, I still do it. Like I just do those curly brackets over and over. Like, look at this talent. And then I flip them and then they go the other way.
I cannot do that.
I know, how good is that? And I just keep going. Oh my God, once that so if you can't do the curly, don't worry about it. This is what I do on my free time. And then you're just going to write your answers out in that order. So 14, 2, -2, -1, 7, and then that's what your final answer would be. So basically, it's just a fancy way of saying there's more than one thing to plug in. So if we're given the domain, we're just given a bunch of things we gotta plug in, we plug them in individually, and then we'll have that many answers, so that many numbers in the range. So that's the idea of that. So we have about 5 minutes left. Why don't you try B? We'll see how far we get. If you want to try another one, that's fine. I know we haven't gotten to everything. I'm just bringing this back tomorrow. There was just a few quick things we needed to clear up. The rest of the stuff is like, will take maybe like 3 or 4 minutes. So just try one or two. Reminding yourself, okay, what's function notation? Where do I put it?